Part 3 of the Week 3 lecture. I now want to go inside this bit in the middle of this slide, which is called Global Energy Systems, and break that up for you so that you have some idea of what's going on in the global energy systems and can start to track things through. So we start with the fuels, the fossil fuels there, and if we add in all the renewables, then all the raw fuels put in together, including, of course, nuclear, constitute a concept called primary energy. And that's how much energy we're sort of taking out of the Earth in any week or year. And where does all the renewables energy go? Well, it goes into electricity. There's no other outlet for it. So it goes into an electricity grid, and then it's distributed through. And of course, nuclear power stations contribute their electricity as well. And there is some coal-fired power stations and oil a bit, and there's also some gas as well. All this electricity then goes into our homes and to our offices and to industry and into transport. And, a lot of rail nowadays, especially in Europe, is electric. We're seeing growth of road transport, very little electric sea transport, and almost none, I think, air transport. But that might change in the course of the next year, the next 10 years, sorry. Okay. And then, of course, power stations are not 100% efficient. They are, in fact, only half as efficient as that. Some of them burning coal are only about 40% efficient, and some, like gas and so on, are about 60% efficient. And that is, if you would compare, the amount of energy in a lump of coal, its calorific value, and then say, well, that's so many kilowatt hours, and then how much electricity do we get out of a coal-fired power station or at the end of the distribution grid, and it's only about 40% of the energy potential, chemical energy, that was in that lump of coal, or that bit of oil, or that bit of gas. So fossil fuels are only about sort of 50% efficient, and there's a huge amount of energy that goes out of the pipes, the chimneys of a power station up into the atmosphere. So they will warm up the atmosphere directly, aside from the carbon dioxide. Now, carbon dioxide does not appear on this diagram at all because it's not an energy product. It's not a source of energy. It doesn't absorb energy. This is just about energy flows. Okay. So a lot of gas is used to make electricity, but of course gas also comes into our homes and offices and into industry as a very useful source of cheap heat. I mean, roughly, if I look at the price of kilowatt hour of energy supplied by gas and electricity, then my gas in my house, I looked the other day, is about a fifth of the price of the electricity per kilowatt hour. But gas can only do certain things, whereas electricity can run this computer, and gas can't do that. So gas is quite good for bulk heating of water and homes and things like that. Oil, of course, has its own value chain and distribution system. All crude oil is refined, turned into petrol, diesel, jet fuel, and all of that, and then off it goes mostly to the transport sector. But a bit of it, of course, goes off into the plastics industry. So if we total up all of the energy that's delivered to the transport sector, to industry, offices, and homes, that gives us final energy consumption. And if you were to add final energy consumption to all of the waste energy that comes out of, well, oil refineries lose a bit, electricity power stations lose a lot, and then we add the final bit of non-energy use from these fossil fuels, then we would get the thing on the left-hand corner, bottom left-hand corner, primary energy. So primary energy is the total amount of energy we're taking out of the Earth in a day or a year, and it goes somewhere. It either goes as waste energy into the atmosphere, usually as the form of heat, or it goes into homes, offices, industry, and transport, all of which is called final energy consumption, or it goes into a feedstock, into the chemicals industry, or steel, or plastics, where it is and should be recycled. Certainly, most steel is recycled these days, and really we must be trying to recycle all of our plastic. Okay, so that is a diagram of what's inside those energy systems and saying, this is what really matters. And at the heart of it, you'll see that electricity power stations are one of the key things, and that's something that politicians can influence in quite a big way. They can ban certain forms of fuel. In Germany, for example, Chancellor Merkel had a lot of nuclear power stations. I don't know, a quarter or a fifth of all the energy used to come from nuclear power stations, and she just closed them down. It was part of a political deal, but she said, no, we're not going to use nuclear power stations. So, you can make political decisions and they have an effect. And the countries like India and China have been providing a lot more electricity because the demand for it is rising astonishingly fast, of course, in homes and offices and industry, but they've had to fuel it with a lot of coal, and that was the policy up until about 2010, 2012 or so, and then China and India have both started to phase down the construction of new coal-fired power stations. There's still a few coming on stream, but those are political decisions. But a lot of these decisions are not political at all. They're actually just you or me deciding to buy a new car or take the bus or go buy an electric scooter or a cycle. Just an everyday commuting decision can actually have an effect on this, and you can track it through like that. So we should move on from here and look at data sources for your assignment. Where do you get data about emissions and global energy flows? And first of all, let's just remind you of the topic. It is global man-made emissions. So it's not emissions in the UK or the US. If you do something on that, you're going to fail because it's not meeting the remit here. Fail on this unit, assignment 1. So it's global. It's also man-made emissions. So there are an awful lot of emissions naturally. I mean, volcanoes, when they erupt, and believe me, there's volcano erupting somewhere in the Andes now, and several in Africa, and a couple in Iceland, and somewhere around the Pacific Ring. Volcanoes emit huge quantities of carbon dioxide, and of course always have done in the Earth's 4.5 billion year history. And then tundra melting, which is a consequence, you might say, of global warming, but we're not going to consider that. That's a natural effect. Trees, when they fall down and die, they rot and they emit carbon dioxide. Yes, you're not going to consider that. Herds of cows emit large quantities of methane, farting. Yes, I don't want you to consider that either. That's a natural emission. You might say that we humans determine the number of cows and that we can influence that by the amount of beef we eat, or the milk that we drink. Yes, we can. But again, I don't want you to consider that. I want you just to look at the man-made and sold energy emissions, which themselves create carbon dioxide. Now, where can you get data from? Well, there's something called the International Energy Agency, and there's a link there to their general statistics source. However, this year, the IEA did a global energy review in April 2020, and that has some very interesting forecasts and measurements in the short run for this year, 2020. And they've said, well, it's going to have very considerable effect. And for the first time in 300 years, we're going to see global man-made carbon dioxide emissions fall as a consequence of the lockdown across the world. And then the question is, what's going to happen beyond there? And they don't address that in their April paper. That's what you do have to address. So there's a good starting point for where we might be in 2020. and should be. I would take that as given because it's as good a guess as anyone can have. Of course, you remember that on the right-hand side of those diagrams we've just seen, there's demand, and that's our needs, and that's fueled by income. So what's happening to the world's economy, the world's incomes, and so on? Well, there was an April forecast by the International Monetary Fund, but they did a June update, which is more interesting because they've had more time to consider things. Have a look at that one and see what they say about what is happening to the world in 2020 and 2021. They don't go much further than that. And of course, there's always a BP statistical review, which is very good. I've used it for many, many years, and that also has greenhouse gas emissions. How do you research or get data about the future? Well, you're just going to have to make projections. Now, how do people make projections? Well, people who do proper forecasts will have a good set of base data for the past. They have a methodology or set of equations, what we might call a model, to derive future demand and supply for primary energy and natural gas. And then they make assumptions that drive their models of world energy. And from that world energy, we get into world demand for greenhouse gases. So we've helped you supply you with an Excel spreadsheet, which is already populated with those kind of things. So the rest is up to you and your group. And there will be a fourth recording where we talk about where we take you through the Excel spreadsheet. So I hope you look at that.